In this module, let's talk about long-run equilibrium and supply. In the long run, firms can enter and exit the market. The short run differs from the long run in a couple of ways. First, in the short run, firms in the market stay as long as price covers variable cost. Remember, they didn't necessarily leave just because they were losing money, as we saw in the previous module. Profits or losses are possible in the short run, but profits attract entry, which is going to shift the short run market supply curve out and reduce prices. Conversely, if firms are making losses, then some of them would exit, which would shift the short run market supply back and raise prices. The big difference between the short run and the long run is that in our model, in the long run, firms earn no profit. That means the long run supply curve and the short run supply curve are going to be different. That's what this module is going to be about. First, let's just see how short-run supply and market demand work together to determine price and quantity. Here we have a market demand curve and the short-run market supply curve that we derived in the last set of modules. The idea is that the market equilibrium arises at the intersection of supply and demand. So the price and quantity are determined by the market demand curve and the short-run supply curve, as these horizontal and vertical lines in this diagram show. This is a short-run equilibrium. Now, in the long run, firms can enter if they see opportunities for profit or exit if they're losing money. So let's consider what this looks like from the perspective of the market as well as an individual firm. On the left, we have the market demand curve and the market supply curve, and there's that price that's being determined by the intersection of supply and demand. On the right-hand side, we have a perfectly competitive firm. Now see that we have the cost curves that we derived previously as well as the demand curve. There's something special about this picture though. Notice how the demand curve is at a price level that's just equal to the minimum of the average cost. What's going on here is that the firm chooses the quantity of output where marginal revenue equals marginal cost. But what's also true is that at that quantity of output, marginal cost equals the price. Average cost also equals the price, so the firm is producing or generating no profit whatsoever. So it's an equilibrium and a long-run equilibrium in the sense that the firm has no profit, and therefore, since this firm shows what every firm looks like, no firm in the industry has any incentive to enter or exit. Let's illustrate how this works. Let's start in a situation where there are positive profits, which are going to attract entry. So what this picture shows on the left-hand side is a firm. You see the marginal cost curve coming up through the minimum of average cost, and you see this price, or the firm's demand curve, that's pretty high. You see the firm choosing profit maximizing quantity of output, which is where marginal cost crosses that green marginal revenue or demand curve. And that big maroon rectangle is the firm's profit. On the right-hand side, you see the intersection of supply and demand that determined the price that firm faced. Well, because there are profits, we expect other firms to enter this market, which in turn should shift the supply curve out to the right. Now, where would this process end? Well, it would end when no firm has any possibility of profits. So it would end where the intersection of the new supply curve and the market demand curve are at the price that's the minimum of the average cost for each firm. Now, this idea of zero profits in long-run equilibrium is pretty scary. But since this is a business school and an economics course in a business school, we should note some important real facts. Firms can make money even as price takers, that is, firms that take the price as given and whose output decisions have no effect on price, if they have lower costs than their competitors. Think, for example, about how Walmart makes money. Walmart doesn't make money by charging high prices. They make money by having lower costs than other firms and by charging prices. Well, actually, they charge lower prices than other firms, but their costs are lower still. Now, why do I say this? Here's some data on the price of a particular product, milk, at various different kinds of stores. Grocery stores, you know what those are, drug and convenience stores, and then the so-called non-traditional retailers in these data, which, by the way, are from the Department of Agriculture, are Walmart and Target, so these big kind of stores. Notice that the prices of these products tend to be lower at these non-traditional retailers than at grocery stores. So you could look at any entry in this diagram or in this chart you want, but for example, for skim milk in 1998, at grocery stores it was $2.27, and non-traditional retailers $1.99. You see this pattern throughout the table. So the point is here that Walmart and Target are firms that have lower costs than other firms, and they make money, as you know. You know that they make lots of money, but it's not because they charge higher prices. It's because they have lower costs. Now, this links with a lesson you learn when you take your strategy course, which is that firms can make money. One of the ways they can do so is by having lower costs than their rivals. But one other feature of the lower costs has to be that they have lower costs that other firms are unable to successfully imitate. If everyone has the same low costs, then the prices would just fall to those low costs, and nobody would make much profit or any profit. But still, before you get too depressed about the idea of zero profits in long-run equilibrium in this model, just remember that a firm producing a homogeneous product, that is, a product identical to the products offered by its rivals, can still make profits if it has lower costs that other firms can't imitate. Now, to get to the big question of this module, which is what is the shape of the long-run supply curve, let's think about what question it answers. The long-run supply curve answers the question, what would happen to costs with a permanent change in output? And when you want to think about why this is interesting, at least for me, it's interesting to think about the really rapid growth in places like China and India. And what this really is rather a rapid change in the demand for lots of commodities. And the question is, what's it going to do to the prices of those products and the inputs required to make them? Think, for example, about food or gasoline. We have here pictures of cars, the Chery and the Tata, cars that are whose demand is growing rapidly, reflecting the growth in demand for gasoline in India and China. And of course, it's a world market for those products, so this big growth in demand may have an effect on prices everybody pays. But let's not get ahead of ourselves. Let's understand the way that long-run supply works. In the constant cost case, long-run supply is just horizontal. The idea is if there's a permanent growth in industry output and associated input demand, this does not drive up input prices. The result is that long-run supply would just look like this, a horizontal line. Let's take a look at how this unfolds. In this diagram, we have a firm on the left-hand side, and so we see the familiar U-shaped average cost curve, the marginal cost curve that comes through the minimum of average cost. On the right-hand side, we see market demand and short-run supply. The price is being determined by the intersection of supply and demand. Notice that that price comes over and functions as the firm's demand curve. This is an equilibrium and a long-run equilibrium because the price is at the minimum of average cost and there are no profits. But now let's set this story in motion by increasing demand. When demand shifts out, we get this new demand curve D2. It intersects that short-run supply curve S1 at a higher price. In particular, this green dotted line. What happens next? Well, in the short run, a firm, represented on the left-hand side, would maximize profits by increasing its output from Q1 to Q2. A firm that looks like this would be generating profits. Those profits would encourage entry by other firms, and that entry would shift supply out. Where would this process end? Well, supply shifts all the way out in the constant costs case so that the new supply curve S2 intersects the new demand curve at the same price we had before, P1. So in the end, Each firm on the left-hand side looks just like it did before. It's just that there are more of them. The important point to note is that the expansion of the industry, which generates more firms, each of which looks like the firm on the left, has no effect on the location of the cost curves. So costs haven't risen. The resulting supply curve is just horizontal. So on that right-hand side diagram, that long-run supply curve, it just connects the old equilibrium with the intersection of D1 and S1 with the new equilibrium, the intersection of S2 and D2. And once again, that supply curve in the long run is horizontal in the constant costs case. We can contrast the increasing costs case to the constant costs case. In the increasing costs case, a permanent increase in demand actually drives up input prices. So what are some situations like this? Well, think about commodities that are scarce, where the only way to produce more of them is to find more and more expensive ones, and so costs are driven up. This quote from Paul Krugman's essay on Finite World illustrates the point. He wrote, oil is back above $90 a barrel, copper and cotton have hit record highs, wheat and corn prices are way up, overall world commodity prices have risen by a quarter in the past 6 months. This was a few years ago, but the point is still relevant. What the commodity markets are telling us, he wrote, is that we're living in a finite world in which the rapid growth of emerging economies is placing pressure on limited supplies of raw materials, pushing up their prices, and America is, for the most part, just a bystander in this story. Well, in this kind of a situation, the resulting long-run supply is upward sloping. Let's consider another motivating example. With some products, firms can produce more only at higher costs. One of the really good examples of this is oil. Now, I'm not a geologist, and this isn't a geology course, but if you look at oil deposits, petroleum deposits around the world, some of them are the onshore Middle East deposits, are pretty inexpensive to get out of the ground. But as you look across different deposits, and what this diagram shows is the different deposits organized by the cost of getting them out of the ground, you see that some of the other deposits become increasingly more expensive to get out of the ground. And so in a situation like this, where there's some stuff that's cheap and other stuff that's more costly to get out of the ground, an increase in demand would drive up the cost and therefore the price. And so you'd expect an upward sloping long-run supply curve. Let's see how this works. What does it look like in our model? So we start with a familiar picture. On the left-hand side, we have a firm in equilibrium making zero profits. It chooses the quantity of output where MC equals the demand curve, and it's also, by the way, the minimum of its average cost. On the right-hand side, we have market demand and market supply. Well, now let's have an increase in market demand. So demand shifts out from D1 to D2, and the price goes up to this new dotted line. Well, firms are going to increase their output, and firms are going to generate profits, and entry is going to occur. But this case is a little bit different than the constant cost case. So let's go ahead and let some entry occur, but note that supply doesn't shift all the way out so that the price falls all the way back to P1. Instead, what we have is that the new equilibrium occurs at this intersection of S2 and D2 with a higher price. Take this price back over to the firm, and what we see is going on is that the costs are going up. So this is the case where an increase in the size of the industry, which drives up demand for the product and demand for the inputs, drives up the cost of those inputs. So the new average cost curve, AC2, is higher than the old average cost curve. And the new equilibrium is the intersection of the dotted line firm demand curve and the new marginal cost curve, MC2. Now, it's true that as before, the firm earns zero profits. But what's interesting, if you look back at the right-hand side of the diagram, is the short-run supply curve is the intersection of the old demand and supply with the new demand and supply. The long-run supply curve for the increasing costs case is an upward sloping line shown by this orange long-run supply curve. What are the takeaways from this module? Well, first of all, profits attract entry, which leads to the zero profit equilibrium. Now, it's going to be zero profits and depressing for everybody unless somebody has a cost advantage, in which case they, like Walmart, can actually make money selling products that are pretty much the same as products that other firms in their industry sell. Second, the long-run supply curve depends on what happens to input prices as the market expands. If costs are unchanged with a change in the size of the industry, then we have constant costs, and the long-run supply curve is horizontal. If costs rise when industry output changes permanently, then we have an increasing costs case, and the long-run supply curve is upward sloping.